The mystery of black holes has captivated scientists and the public alike for decades. These enigmatic objects, where the gravitational pull is so intense that nothing, not even light, can escape, have been the subject of countless theories and investigations. Among the most intriguing ideas is the possibility that black holes could contain alternate dimensions. Could these celestial bodies serve as gateways to other realities? Is it possible that when something enters a black hole, it doesn't simply get destroyed but rather transported to an entirely different universe or dimension? To explore this fascinating question, we need to delve into what black holes are, how they function, and what leading scientific theories, such as general relativity and quantum mechanics, have to say about the nature of space and time within them. We also need to examine the possibility of higher dimensions and what recent theories in physics suggest about how alternate realities might be hidden within the very fabric of black holes. A black hole is a region of space where gravity is so strong that nothing, not even light, can escape its grasp. Black holes are formed when massive stars collapse under the force of their own gravity, creating a singularity, a point of infinite density where the laws of physics, as we understand them, break down. Surrounding this singularity is the event horizon, the boundary beyond which nothing can return. Once something crosses the event horizon, it is lost to the universe as we know it. Time and space inside a black hole behave in ways that are drastically different from how we experience them on Earth. For example, time is thought to slow down significantly as an object approaches the event horizon, a phenomenon predicted by Einstein's theory of general relativity. In theory, from an outside observer's point of view, an object falling into a black hole would appear to freeze in time as it reached the event horizon. General relativity and black holes. Einstein's general theory of relativity has been the cornerstone of our understanding of black holes. It describes how massive objects warp the space around them, and nowhere is this warping more extreme than inside a black hole. According to general relativity, the singularity at the center of a black hole is a point where spacetime curvature becomes infinite, and known physical laws cease to function. But what happens to the matter and energy that enter a black hole? One of the key puzzles scientists grapple with is the information paradox. According to quantum mechanics, information about physical systems should never be lost. But if everything that falls into a black hole is destroyed at the singularity, where does that information go? Could it be that black holes are not the destructive cosmic vacuums we imagine, but instead serve as bridges or portals to other dimensions? The concept of alternate dimensions is not as far-fetched as it might seem. In fact, string theory, a leading candidate for a theory of everything, suggests that our universe is made up of multiple dimensions beyond the familiar 3 dimensions of space and 1 of time. According to string theory, there may be up to 10 or 11 dimensions, most of which are hidden from our perception because they are curled up at scales too small to observe. Could black holes provide a way to access these hidden dimensions? Some physicists believe that the extreme warping of spacetime inside a black hole could allow for connections between different parts of the universe, or even between entirely separate universes. This idea is sometimes referred to as a wormhole or Einstein-Rosen bridge, a theoretical tunnel through spacetime that connects 2 distant points, or perhaps 2 different universes. If black holes are indeed connected to alternate dimensions, it could explain some of the mysteries surrounding them. For example, the so-called firewall paradox suggests that anything falling into a black hole would encounter a wall of high-energy particles at the event horizon, effectively destroying it. But if black holes serve as portals to other dimensions, the matter and energy entering them might not be annihilated but instead transported to another realm. While general relativity provides a powerful framework for understanding black holes, it doesn't account for the behavior of quantum particles at the subatomic level. This is where quantum mechanics comes in. The problem is that general relativity and quantum mechanics don't play well together. Each works beautifully in its own domain, but they seem to contradict each other in extreme conditions, such as those found inside black holes. This conflict has led physicists to search for a quantum theory of gravity, a unified framework that could explain both the large-scale structure of the universe and the behavior of subatomic particles. One of the leading contenders is the holographic principle, which suggests that all the information contained within a region of space can be described by information encoded on its boundary. In the case of black holes, this means that all the information about the matter that falls into a black hole might be stored on the event horizon, rather than being lost inside the singularity. If this is true, it could open the door to alternate dimensions. The holographic principle implies that our universe might be a kind of hologram, with all the information about the three-dimensional world we experience encoded on a two-dimensional surface. If black holes follow the same principle, then the information entering them might be preserved in ways we don't yet fully understand, perhaps through connections to other dimensions. The multiverse hypothesis. One of the most intriguing ideas related to alternate dimensions is the multiverse hypothesis, the idea that our universe is just one of many universes, each with its own set of physical laws and constants. Some versions of string theory, as well as the theory of eternal inflation, suggest that new universes are constantly being created in a vast multiverse. Could black holes be gateways to these other universes? Theoretical physicist Lee Smolin has proposed a theory known as cosmological natural selection, which suggests that black holes might give birth to new universes with slightly different physical properties. According to this theory, every time a black hole forms, a new universe is created inside it, potentially with different laws of physics than our own. If this is true, then entering a black hole could be a one-way trip to a completely different reality. Another important factor to consider when discussing black holes and alternate dimensions is Hawking radiation. Proposed by physicist Stephen Hawking in 1974, this radiation suggests that black holes are not entirely black but slowly lose mass over time as they emit particles. Eventually, over the course of billions or even trillions of years, a black hole could evaporate completely, leaving behind nothing but radiation. But what happens to the information that fell into the black hole? If black holes truly evaporate, does the information they contain vanish as well? This is the essence of the black hole information paradox, which continues to puzzle physicists. Some believe that the information might be released as the black hole evaporates, while others think it could be preserved in alternate dimensions. At this point, the idea that black holes could lead to alternate dimensions remains speculative. There is no direct evidence yet to support the existence of higher dimensions or multiverses, let alone the idea that black holes could act as gateways to them. However, ongoing research into quantum gravity, string theory, and the nature of black holes is shedding new light on these possibilities. In 2019, the Event Horizon Telescope captured the first-ever image of a black hole, located in the M87 galaxy. This groundbreaking achievement has opened up new avenues for studying black holes and testing the predictions of general relativity and quantum mechanics. Future observations and experiments could provide crucial insights into the true nature of black holes and whether they connect to alternate dimensions. The idea that black holes could contain alternate dimensions is one of the most exciting and speculative topics in modern physics. While we have yet to find definitive proof, recent developments in theoretical physics suggest that black holes might be more than just cosmic vacuum cleaners. They could be portals to other universes or dimensions, where the laws of physics as we know them no longer apply. As our understanding of the universe continues to evolve, the mysteries of black holes and their potential connection to alternate realities will remain at the forefront of scientific exploration. Could black holes be the key to unlocking the secrets of the multiverse? Only time, and perhaps a journey beyond the event horizon, will tell.